When I was in high school, I decided to take it one step further, and I decided to build an atom smasher, a particle accelerator in my mom's garage. So I assembled 300 pounds of transformer steel, 22 miles of copper wire, and I assembled a 6 kilowatt, 2.3 million electron volt betatron particle accelerator in my mom's garage.
In high school?
In high school, right.
Wow.
Every time I turned it on, I would blow out every single circuit breaker in the house. It consumes 6 kilowatts of power. My poor mom comes home, and she hears this pop, pop, pops out as I blow out every circuit breaker in the house. And she must have said to herself, why couldn't I have a son who plays baseball? Why not basketball? And why can't he find a nice Japanese girlfriend? How come he builds these machines in the garage? Well, that machine got me accepted to Harvard, and that began my career. That began my career as a theoretical physicist.
What were you able to do with that machine?
Well, I was able to create a magnetic field of 10,000 Gauss. That is 20,000 times the Earth's magnetic field. If you got too close to my machine, it would pull the fillings out of your teeth.
Really?
Yeah, so you had to be very careful.
What about objects that are close to it?
Scissors and things would
Hammers.
Fly in the air, right? So you had to be very careful coming next to my machine.
Oh my God! So compare that to you can't even go near one of those scanners, those MRI machines, right? Magnetic resonance imaging.
That's right, MRI.
You can't have any metal near those, right?
Yeah,
but that's
right.
nothing like.
And they're about 10,000 Gauss too, about the same magnetic field as my machine.
Oh, okay.
So my machine is comparable to the machines that you see in the hospital today.
Wow. That's crazy. And you built that when you were in high school?
That's right.
Is that a photo of it? Well, that's a photo of one of those?
Yeah, that's the photo of it right there. You see on the left, you can see that's 22 miles of copper wire. You see the capacitor bank, a cloud chamber on the right where I photographed antimatter, because that was the whole experiment, to play with antimatter.
Wow.
And yeah, the cables are hooked up, and it's hooked up to 6 kilowatts that comes out of the wall socket. Drained every single ounce of power from my mom's garage.
Wow.
Yeah,
look at young Michio. Look at you handsome fella.
Well, that's the betatron particle accelerator.
That's amazing.
2.3 million electron volt generator of electrons.
So you were able to photograph antimatter with that?
Well, with the cloud chamber, yes, I was able to photograph the tracks of antimatter, tracks of positrons or anti-electrons that are emitted from sodium-22. And I proved that it was antimatter because they bent the wrong way in a magnetic field. Ordinary electrons should bend clockwise. These bent counterclockwise in a magnetic field. That proved conclusively that it was antimatter that I was photographing.
Wow. How old are you at the time?
I was about 17.
I was so dumb. I'm pretty dumb now, but I was so dumb when I was 17. That's amazing, thinking you were spending your time doing this.
Right.
I was listening to Led Zeppelin.
But, like I said, I was chasing after this dream of an 8-year-old child, wondering, is there a theory of everything?
It's an amazing dream.
Yeah.
Now, where did you get the designs for this?
Oh, well, these designs come from an X-ray machine done by Donald Kirst, who was one of the inventors of the Betatron. And so a lot of the groundbreaking work was done by him. And now they're incorporated in most hospitals. Most hospitals have one that creates X-rays for patients.
So was there a schematic online that you duplicated? Did you devise this yourself?
There was a schematic online. I mean, there was no line back then. In the library.
Course, online. Excuse me.
In the library there was a schematic, but I had to fill in the details. I had to do the equations to calculate how many turns of wire, how many Gauss. I needed 10,000 Gauss in order to bend tracks of 2.3 million electron volts. All the calculations had to be done ahead of time to make sure it would work.
Isn't it funny that the universe is so common the internet rather is so common that I automatically for a second forgot that we were children when you were younger than me, or when you were younger.
That's right. There was no internet.
There was no internet at all.
Nothing online back then.
It was just books.
It was just books.
So you had to have a real hunger for information to go and seek this stuff out.
That's right.
Did you have any particular high school teachers that were influential or inspirational?
Well, fortunately, I grew up in Palo Alto, which is now ground zero for Silicon Valley. So luckily there were other physicists in the area because they worked for Vernon Associates and different electronics companies. So it wasn't a total vacuum. I was able to get advice, especially on the magnetic field and the cloud chamber, and also the vacuum tube that contained the particles that I was accelerating. It was good to have real physicists there in Palo Alto because of that fact.
Oh, that's amazing. So were they willing to consult with you and discuss this with you as a high
in
school
general,
student?
right. So I would talk to them about how to build a magnetic field and to calculate using Maxwell's equations the geometry of the particle accelerator. So I would go and visit these physicists because Palo Alto was to become ground zero for Silicon Valley.
It's such a fascinating image of seeing this one super genius physicist who's teaching classes get a visit by a teenage super genius physicist. And he's like, oh, he's one of us. And catch you when you're a teenager. That's very interesting.
As soon as I talked to them, they immediately knew what I was doing, so they would help me.
That's crazy.
Yeah.
That's so awesome.